Module 4, Application. This course will address content regarding potential and kinetic energy. Students will be identifying and learning about these two forms of energy by analyzing articles, watching videos and simulations, participating in discussion posts, and identifying real-life phenomena. Checks of understanding will be assessed using different methods of formative assessment throughout the course. A summative assessment will be completed by students at the end of the course to show mastery of the objectives. This will require students to create a visual and description of a demonstration or experiment that accurately displays the flow from potential to kinetic energy. A presentation tool of their choice may be used to exhibit their proficiency of the topic. There are 3 objectives that students will be required to demonstrate mastery of throughout the course. These objectives are as followed. Objective 1. Given a computer and Google Classroom, students will define potential and kinetic energy by explaining real-world phenomena they observe through multimedia. Objective 2. Given a computer and Google Classroom, students will identify the similarities and differences between potential and kinetic energy by comparing the characteristics of each using a graphic organizer. Objective 3. Given a computer and Google Classroom, students will create an accurate demonstration that illustrates the transfer from potential to kinetic energy by using a visual presentation tool of their choice. This course will be targeted towards a group of 6th grade science students. Their ethnicity is Hispanic and they all attend Title I low-income school. They're a diverse group of learners and most of them are at grade level. However, 2 are below reading level. To assist them in their learning, the course will offer text-to-speech options for articles, multimedia that will enhance their comprehension of the topic, and it will include graphic organizers to help generalize new knowledge. This course will take place 100% online, which will require all students to have a laptop or desktop computer available with reliable internet. All coursework, assessments, and feedback will be completed on a digital interface. Here, students will be watching videos and simulations online as well and communicating through an online communication tool such as email and discussion boards. There are many instructional strategies that will be used to assess students on multiple levels that are listed above. These strategies will be used to make sure students are meeting objectives and mastering the content in the course before applying their knowledge using higher level thinking. The Potential and Kinetic Energy course will require students to partake in activities that occupy and engage them. First, simulations will be used as a form of multimedia to help students identify these two forms of energies in real-world situations. Seeing these phenomena will help them to make personal connections to where they have seen these energies in action before. Second, communication will be another type of engagement tactic used to keep students connected and learning from each other. Students will participate in discussion board responses in addition to providing positive and constructive feedback to their peers on the draft of their summative assessment. Lastly, students will stay engaged by creating a demonstration through a presentation tool of their choice to show an example of potential and energy transferring into kinetic in the real world. There will be multiple ways to assess the progress of students throughout the course through formative assessment. Pre- and post assessments, discussion board responses, personal blogs, and misconception check, as well as using mind maps to compare these two types of energies, will be forms of evaluation. The summative assessment for the course relies heavily on students creating a presentation where they showcase their knowledge of how potential energy turns into kinetic. This is done by the students using a presentation software of their own to design and explain a real-world phenomena where this transfer of energy occurs. They will share their draft with a peer to receive feedback before submitting it as a final grade. Here are the references used for the presentation.